All right, here we go. So I wanted to kind of make a computer from scratch, and I'm not talking about like buying computer parts and putting them together. Um, I'm talking about like kind of building your own RAM or a CPU, but like a very simple CPU or RAM. And I've thought about in the past of getting like a breadboard or something. I don't know a lot about that stuff, and I haven't really ventured in too far deep, but I know enough. I think I can make something simple like my own computer maybe in Reaktor. And I've seen people do this type of thing in Minecraft, but it feels like not a good place to do that. But, whatever. This might not be even like a super good place either, but probably a better place than Minecraft because it's actually a programming environment. It's meant for audio, but this is actually where I first started programming. Um, for I actually learned how to program in Reaktor, which is a very strange starting area. But yeah, that was like 12 years ago. I don't know, a long time ago. But anyways, I made this macro called NAND. And if you know what a NAND is, it's not and. So if I put, two inputs in, right? Boom, boom. So I think today I want to make, just to make some memory. And it has memory in Reaktor, but I'm trying to only use this. And maybe if I want to get away with using as little things in here as possible. Um, so I can actually kind of make it from scratch. And this might go terribly. I don't know. I guess we'll see how it goes. So, what a n and or NAND, I don't even know how you say it, is any if any of the two inputs is off, then the output will be on. So if they're both off, the output's on. If they're both on, then the output's off, right? So if any one of them is off, the output's on. Um, so yeah, apparently you can make like a memory from this, and I was trying to find like something to like show I don't know, schematics. I don't know what you call it. Where's books? Where is my books? I capitalize books. Oh, you know what? This is very confusing because I have like several like I don't know why, but Windows decides to make more than one folder to called documents, like one for the cloud. And I tried to get rid of the cloud because I don't want to use it, but it still makes a folder called cloud, and it's really annoying. And now I have two different like document folders. My nose is running. I'm sorry. I'll be back. I gotta get some tissue paper, man. All right, that is like a million times better. Huh. All right. So books. Uh, uh, I know I have a folder called books. Well, I know the last book in Adobe Reader was the book that I'm trying to find. So maybe if I open it, it'll just kind of go to it. Yeah, well, there you go. All right, well, that worked. So gotta find the chapter. I was trying to look for like a diagram of how it looks. This just talks about the gates. Ugh. Excuse me. Oh, there we go. I think this is, yeah, this is it. Well, I don't know how far into making this I'll make be. So, well, we need a register. Oh boy, this is gonna take a lot of work. I know that, but I still want to do it. Um, this is the memory. Let's not make RAM yet. I just make the memory thingy. Aha, this is what I'm looking for. So this is just NAND gates. Oh, this is kind of weird, but I'm gonna try it. And the cool thing is because Reaktor is like modules and it has like wires and stuff, it can kind of, it might be a little easier than programming. I mean, you could, but I don't know, this just looks, so you can actually see the layout. And I don't know, it's easier to visualize, and especially when you're making something that's like, you're gonna repeat yourself a million times. And like, I don't know, the way this is, it might be a little harder to program. As in with, written language. But so we're just gonna do some copying, paste, move this over to the right, left, move this over here, duplicate that, do one of these. It would be nice if we could like make it kind of like do 90-degree turns, but I know Reaktor doesn't let you do that. I don't know the last time they've updated this thing. I have no idea. I already know there might be a weird thing. This loop here might cause an issue, and I wonder if I have to do like one of, I don't 100% know if it's gonna work, but I might have to do one of these, make these like not solid. Can't remember exactly what that does. I think something about looping. Might have to look back in the manual for that because I don't quite remember. Um, and it looks like what we're gonna need is a merge right there. But yeah, this could go terribly wrong. This might not do anything. This is weird. It goes like this. Then it goes up into here like that. But then this goes here. This goes there. Is that how it really, or would it go like, I can't do that. I think it would, I think, well, who knows? Well, and this we can name I and S, right? Holy cow, the background audio. This, it looks like, I don't think I'll need a merge. We can just do that. Ah, I wonder if I can look, go to memory. Can I look inside of here? Yeah, that's this thing. Do you remember? Na 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 na. Da 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 da. Mm. Why am I singing that song? I don't even like that song. Okay. Well, I already see some problems that could probably happen with this. So what is this? That's the input, and then S is the set. Uh, so far it hasn't caused any problems. Let's make the input 12. Okay, well, it outputted 12. I gotta remember how this works, though. And I think it just... Okay, yeah, that just is gonna keep that memory there. Now, if we want to put a new thing in there... Now, it does add... Why does it go to 13? Okay, this is 12. 0. Oh. Oh, I'm dumb. Yeah, I think what I'll need... That is 1. See, this should output false. That's 1, and this is 1, so this should be 0, yeah. This is 0, but then this one is 1. That should still be 0. Then why does this output 1? This could cause issues if I do this, but... Uh, this is 1 and 0, so this should output 0. Watch, 1, 0. Output 1. Oh, I'm stupid. Yeah, if one of them is 0, then the output is true. In this case, it's because the set bit... Zero, 0. Wow. I've already hit an issue, didn't I? 1. Both inputs are 1. One of them is 0, so this is going to output 1. I think the problem is the fact that we don't have latches to control when it goes through. I'm just going to shoot something in the wild and say that's could be the case, but I'm not entirely sure. So I think we still need a latch. So the output can go through here when set. So this will also trigger this as well. Yeah? Maybe? Let's create step size 1. Just go from 0 to 1 like that. Yep. Duplicate that. Call this one I. So we're going to set that value of 0. Now we put 1 in there, and then we're going to set it. Now I put 0 there, and we're going to set it. Oh, did that work? What? Now I don't think I can do other values. So if I put like a different number here, so let's just yeah, if I change this to like 12, does it set it? Now try a different number. It looks like it's working. Wow. No, it's not. No. Yeah, I figured that wouldn't work. My brain was thinking about that and was like, yeah, no. All right, well, let's set it back to go from 0 to 1 again. Now what we need in order for it to save the memory, this is so it can, so if I go with the value 0 or 1, this works. This is fine. Right? But just trying to think about this. I think I could use another latch. Call this like value. Uh, this is where it gets kind of stupid because I only want to output the value if it's 1. Because we're not really messing with electricity here. That's the thing. So I might kind of cheat. Greater than 0. Oh, it sucks though, because I can set the value 1 or I can set the value 0. You know what? That might just actually be what we need though. Yeah, I think that's actually fine. Because I think all we need is a 1 or a 0, whether there's presence of the current or not presence of the current. We didn't actually do the non-solid thing. Still don't remember what that does. Something to do with looping. I'm going to save this as There you go. And then help. Let me look at the documents. What? I don't know why my web page is stuck on always opening these tabs, but whatever. No, I'm looking at getting started. No. Diving deeper, I think. Building and core. Okay, that's it. Does that have to do with routing and merging? Where does it talk about loops? I might just go through everything. I can just, what is it called? Solid. Just look up the word solid. There we go. Solid controls the solidity of the macro, affects the resolution of the feedback loop. See section. There we go. Non-solid macros and feedback loops. The solid property setting of the macro is affecting how the macro is treated in respect to the feedback loops. Solid macros cannot be entered by feedback loops. Okay. Okay. We need to test this to make sure to see if it's actually setting this. So we're gonna make, because in memory we're gonna have like multiples of these. Duplicate this like a few times. Actually new macro. Copy this. Paste it into here. Call this M. And then I don't know, make it medium so it looks a little different. Small. Whatever, it doesn't really matter. We're gonna need a few of these. So duplicate them a few times. Let's just do 4 for now. And then we're gonna have some merges. Do we need a merge? I don't think so. New input, and it's gonna be connected to all the sets. Call this S. Call this I. Do you remember? Perfect. Now this should output 4 bits. So it's going to input. Shoot. We're going to need more than one. Oh, I'm stupid. We're going to need an input for each bit. So that's one bit. This is another bit. Another bit. Input for another bit. Input for another bit. Trying to line this up perfectly is kind of not easy, but whatever. And then it's going to output the 4 bits that it saved. Perfect. So, we're gonna have this numeric output for the 4 bits, or a nibble, whatever you want to call it. I think it's called a nibble. I think that's the actual name of 4 bits. Control, and I'm gonna make this a button. Change this. Is there a type? No. Built button. Go to 1 or 0, trigger. Perfect. Now, it's the bottom one. It's the one above that. It's the one above that. It's the one above that. Here's the button. Call it set. And then we want to be able to do, let's just create a lot of buttons. Whether they're on or off. Perfect. Put this to the left like that. Duplicate that. And then we'll call this, we'll number it 0 through 4 for the bit number. Bit number 0, bit number 1, bit number 2, or 0 through 3. Bit number 4, or 0, 1, 2, 3. Now, what we're going to do is see if this actually saves this. So they're all on. Now I'm going to turn some off, set it. When I turn these off, oh, look at that, it saved it. No way. I think we just made the first part of the memory. Now let's change this around. What if they're all off? Saved it. Some of them are on. Oh my goodness. We did it. Yeah, baby. That's what I'm talking about. That's what it's all about. So we made this M thing. Well, we made a few of them stacked on top of each other. This is what we did right here. And now let's make 8 of them. We need the enabler too, or whatever, this thing, which is, what is it? A bunch of AND gates connected together. So we need to control when we want to enable the memory. So, and let's make the and from scratch too. I'm gonna only use these, and we're gonna need latches too. But I'm gonna try to get away with only using this NAND. So before we do that, we're gonna have to make, so, well, let's make this 8 bits, because it's how many bits are in a byte. All these are connected, all those are connected. Perfecto. Duplicate those. Rename them. Seven. See, computer science isn't that hard. Right? Duplicate this. Man, Reaktor is like so good for, I mean, I might be like eating my words in a second, but so far it just looks freaking amazing for doing this type of stuff. Like just for experimentation to see how stuff works. Man, I know like if I don't think it'd be good to like write actual programs in all the time, but um like the visual, like just visually seeing how things work, it's freaking amazing at that. So I just send these 2 bits and see if it saves it. Yeah. Oh my goodness. We got a piece of memory. Now I gotta do the enabler. So how do I make the and out of just, I'm gonna be lazy and just look at what they did and try to kind of copy it, I guess. Uh, maybe, does it not talk about it yet? Yeah, it does. I've seen it done. I think it said it down there and I just skipped it. Okay, maybe it's not that. Sorry, I can figure out how to make an and, probably without looking at this. This new core macro. We're just gonna use the bare minimum. Oops, just use this. Call this and. We need 2 inputs. Paste and 1 output. So that's a NAND. So it's kind of close. Well, it's not close to what we want. So how are we gonna do this? So in this case, if they're both off, it's on. And if one is, if one of them is off, it's on. So oh, this is an and right here. If they're both, looks like they just merged them both together or something. Maybe? I don't think it'd look like that. I think it'd probably be like, so A is true. Two input A and B and tie them together. Oh, I see. Do I need a merge? I don't know if this will actually do it. It's worth seeing. I'm gonna test this out. Well, I wish there was a better way to test stuff. Like, obviously, yeah, you very much so would not want to program in this. Like, you much rather use a written language than this, but okay, well, that didn't work. They're both 0, it's off. Only if what? Okay, it's just a regular NAND gate. Kind of. No, not really, is it? I kind of see what's happening though. I think what I need to do is this one's the top, this one's the bottom. I need to make this one the bottom and then this one the top, maybe? Maybe? Okay, they're both off. Now they're both on. One off, one on. I almost made an OR gate. Yeah, I just made an OR gate. No, I didn't. Yeah, it's definitely not an AND. Okay, so this is no. Wait, off. So this is would be an OR gate, right? Maybe. We'll see. So yeah, okay, they're both off. One on, one off. No, it's not really. It's not an OR gate. Mm-hmm. I don't freaking know. Both off. I need a. Beginning to see what's the problem here. Uh, Problem is we need to test the existence of current or no current. If one is it, it would both be false. You know what? Because I need to test the existence of current, I feel like I kind of have to cheat. I have to use a comparable. I would have to use this to test to see like if this is greater than 0, if there's then I'd have to merge these together. I don't know how else to test, you know? Okay. So far, so good. Just let me change the constant. No. No, definitely not working right. That's weird. What? Oh, you know what? Um, yeah, this gets weird. I need to do it like this is greater than 0, then route it through. That's what I really need to do. But then if both of them are not greater than 0, see, this is a 0 and a 1. So this output should be 1. 0, 1. Unless it's because of the timing. Because there was no event to trigger it, maybe, but what the hell? It's greater than 0. Oh, you know what? This kind of makes sense. Because one of them has to be off. Okay. Now this event should trigger that. Yeah, okay. If they're both on, it'll be off. Not just the regular NAND gate, though. So the only thing is like, we need to get rid of the case where they're both 0. Right? So what we could just do, instead of doing all this, because it's pretty much, the NAND gate's already pretty much correct. I don't know why I'm making it so complicated. I could just, they're both off, it's on. Oh, we're trying to make a NOT gate. I didn't even read it. Um, how do I turn this into a NOT gate? So right now, if they're both 0, it's true. If they're both 1, it's false. We need to flip that. What if I just switch? That wouldn't do it. If I took this, seems like way overcomplicating it. So this isn't going to quite be it, but it's going to be maybe the opposite of what the AND gate does. Yeah, so now they're both 1. Only when they're both 1, they'll be on. This is 1, and this is 0, it's off. Or if they're both 0, it's off. Okay, yeah, I guess that's our AND gate. It's the only way we could do it, really. Only way I can think of doing it. Because it's not electricity, we gotta do it a little differently. All right, so we made our AND gate. Now from the AND gate, we need to connect it to take this, paste it here. I guess what we're doing is, if they're both off, it's okay. If they're both all right, we got our AND gate. That's what we needed. No more messing around with this. So now, because we have the AND gate, we can set up the enabler, I guess. Right? I think we can just link all these together and make an E down here. E. E, A, E, E, E. It's in the game. I'm going to put the little EA Sports. It's in the game. E E E E E E. It's a different way to make an AND, but you know, it's the only way I could think of doing it. Because we're not actually messing with electricity. Instead, we're just messing with ones and zeros. Boom. See if this enabler works. Create another button. Call it E enable. Now we're gonna save our bits. Set. Oh, didn't do anything. Oh no. Oh, I just realized this needs to be a gate. Yeah, okay, so not what we want. What's going on here? Why are they all? Oh, okay. So now it's gonna, yeah. So it's gonna be like, okay, I want you to send this bit through. Boom. Let's uncheck this. Oh, it saved it. Oh! Now it reset it. It reset it because I initialized Reaktor when I went back to the different part of the ensemble. Ensemble? I don't know how they call it. So I'm gonna set the sequence of bits on 2, 4, and 7. Set. Wait, I gotta enable. Do I have to enable it first? I don't think so. Enable. Oh, look at that. It saves. It's crazy. All right, so because I don't want to make crazy long videos all the time, I'm gonna cut it short here. I'm gonna work on more of this later. But yeah, this is the first part of the computer. It's it's not quite RAM, but we're getting there. We're getting there.